In this section of the lecture, we'll talk about object-oriented design, how to document it, and we're going to talk about UML diagrams and talk somewhat about requirements and tests. However, we'll talk more about requirements and tests in the project lectures on Friday. So first of all, let's talk about unified modeling language. The unified modeling language, remember the goals of the object-oriented paradigm. The first was data encapsulation, hugely successful. The second was code reuse, somewhat successful. People were hoping that you could basically do component-based software design, where you could just pick and choose some software components that were previously designed, stitch them together, and they would magically work, and that just hasn't worked out much at all. However, there has been a lot of reuse through this notion of inheritance. And then the third was about software understanding. This is a huge problem. It's an intrinsically difficult problem. Nobody knew or understood the software that was around prior to the object-oriented paradigm. There were other forms of attempts of trying to improve software understanding. There was block-based design. There was an entire programming language called Ada that was supposed to solve the problem. It didn't. Notice that you're not being taught Ada in your college classes. With the object-oriented design, people tried again, and we still don't understand. It's a difficult problem. However, one of the techniques to try to improve software understanding was by representing the software graphically through something called the Unified Modeling Language, or UML. Unified Modeling Language is actually a sequence of diagrams, 7 to 9 different kinds of diagrams. In this class, we're only going to worry about class diagrams. They show the structure and the relationship between the different classes in the program. So in order to do that, you first need to create a single class diagram, and it's pretty straightforward. Here's the sheepdog game. You make a box, and inside the box you put the name of the class, and then you list every attribute. And the way you list every attribute is if the attribute is private, you put a minus sign in front of it. If the attribute is public, you put a plus sign in front of it. Then the name of the attribute, and then a colon, and then its data type. So I'm thinking, okay, for my sheepdog game, I need a generic animal, and then I'm going to extend the generic animal to sheep, and I'm going to extend it for dog. What does a generic animal need? You go through this process of, okay, what do I think these classes need? I think every animal should have an X location, a Y location, an X speed, a Y speed, and and a max speed. So since all my attributes are private, they all are preceded by the minus sign, then their name. They all happen to be doubles, so it's colon double. After you list all the attributes, you list all the methods. You don't list the code, you just list the method signature and the return type. Same rule applies for visibility. Negative for private, positive for public. All of your attributes should be private. Almost all your methods will be public. So I have public move, plus sign move, no input required. Its return type is void. There really probably isn't another need for another method, but I put vocalize in there so the sheep can bleat and the dog can bark. And plus sign for public, vocalize, no input required. It doesn't have a return type, so it's void. That's a single class. Now to show the relationships between classes, you connect them with these different connectors. The has-it relationship is shown with a line with a diamond at the end. The is-a relation is shown with an arrow, so it's a line with an arrowhead at the end. In the has-a relationship, the diamond goes to the class that has the other class. So in this little diagram here, class A has one or more of class B. I'm allowing multiples, so the diamond is not filled in. Here, if you know you have exactly one, it would be class A has exactly one of class B. If you know how many you're going to have of class B, let's say you wanted to have 5 of them, you can put the 5 as a notation here above the line. The is-a relationship is shown with arrows, and the arrow points from the child to the parent. So class B extends class A. A is the parent, B is the child. When you're drawing these, do not use hand-drawn. Use PowerPoint. Use some online tools if you need to. I'm not a big fan of the tools because you understand it better if you create it from scratch. It's pretty straightforward to do these things in PowerPoint or any kind of a graphics program that allows you to create boxes and connectors. If we go back to the sheep-sheepdog game example that we started the semester with, I know that I have a dog, one dog. I know that I have sheep, multiple sheep, I'm assuming 3. And I know that I have terrain. We just, you sit down and you ask yourself, what classes do I need? Well, those are 3 classes I know that I need. If I start to create the sheep and the dog, I realize, well, gosh, they're awfully similar. So maybe I should do a generic animal and then extend that generic animal. The sheep can extend generic animal. The dog can extend generic animal. So those are the most obvious classes that people will come up with. We need a generic animal. The sheep extends the generic animal. The dog extends the generic animal. Now for the dog, notice I don't have any additional attributes. The dog inherits all the attributes and methods of the generic animal, but it will overwrite the move method. The dog moves based on user input. The sheep move by running away from the dog. So that we will change the move method. And the same for the sheep, we'll change the move method. You'll notice though I added some attributes for the sheep, and I'll talk about that in a minute. The less obvious classes that you need though, you do want a class, or you may choose to have a class, that actually runs the game, that acts as the game manager, the game controller. And so I'll have a game, I'm going to change that to controller. I'll have a game controller, and it has attributes of terrain, sheep, dog, and a timer because I want to keep track of how long it takes for the player to get the sheep in the pen. I might need more. Let's see. The terrain contains the pen information and the length and width of the field of play. So that's probably all I need. Excuse me. We have 3 sheep, so I'm going to indicate that as an array of sheep of size 3. If I don't know how big it is, I'll put N there or just blank, a blank set of brackets. Because I have multiple sheep, the diamond is not filled in. But because I have exactly 1 dog, I fill in the diamond. Because I have exactly 1 terrain, I fill in the terrain. So we're showing the has a relationship. The game controller has terrain. The game controller has a dog. The game controller has sheep, multiple sheep. And then I've got some GUI classes out here to show everything to the user. I'm not ready to detail those yet, so I'm not going to require that you do that in your P3 deliverable either. Now what may seem strange to you is I've also got where the sheep contains a dog and the sheep contains terrain. These are design decisions. Excuse me. If the sheep are supposed to run away from the dog, the sheep needs to know where the dog is and what it's doing. So we have 2 methods to do that. One is the game controller can say, "Where are you?" to the dog, and then tell the sheep where the dog is. And the game controller say, "What direction are you running in?" and tell that information to the sheep. Or we can let the sheep actually have its own dog class, and then we don't create 2 dog objects, we only create 1. We create a dog object up here in the game controller, and then the game controller sets the dog object in the sheep class to the same thing. Remember, when you pass a handle in for an object, what you're really doing is passing in the memory space. So what we're doing is we're giving the sheep access to the memory space where the dog information is kept, and now the sheep can determine on their own where the dog is and what direction the dog is going, and then we can write the move method based on that information. The same design decision occurs when you say, well, the sheep shouldn't be able to run out of bounds. Well, is that the job of the game controller, or is that the job of the sheep? And there's no right answer. And quite frankly, can be a tough decision sometimes. And no matter how long you're coding, it can remain a tough decision. So what I've chosen to do is the same trick. I'll let the sheep have a terrain object in it. We create that terrain object up here in the game controller, so the game controller knows about it. But then the game controller passes that handle down to the sheep, and now the sheep know everything about the terrain, so they know where they are. And we can, within the move method for the sheep, prevent them from running off the edge of the board, or once they get into the pen, prevent them from getting out. Same thing for the dog. How do I figure out that the dog doesn't run off? Well, I can create a terrain object in the dog also, or I can let the game controller handle it. So here my top level design is I'm going to let the game controller handle that. Now, there's not necessarily a correct way to do this. These are design decisions. You may regret some of your design decisions later and change them, and that's called normal. That's okay. Before we leave this slide, I'm going to fix this. I don't know how it changed. Okay, there we go. Okay. So what's the process for doing this? I'm going to give you two versions. This is the one that more closely corresponds to what we're doing in this class. The first thing you do is you create your user stories for the project. You've done that with your P2 delivery. You create your user stories, their priority, and their effort estimate in terms of hours. Then you develop requirements and test cases for each user story. Now I'm saying each user story because that's normally how you would do it in the process. I'm only requiring in your project that you develop test cases, requirements, I think 12 total requirements maybe. So you don't have to do all the requirements for the whole project. You have to do some to get practice in creating requirements. And then for each requirement, we 3 test cases. I think it's 5 requirements and 3 test cases. We'll have to look at the project docs for that. Then you go through and determine your classes. Oh gosh, what classes do I think I need, and what attributes do they need, and what methods do they need? So I'm going to go through and say, okay, determine the classes, determine the attributes, determine the methods. And again, this may change. What I mean by this may change is as you go through the design process, you may find that you need additional attributes, or you put a method in the wrong class, or you put an attribute in the wrong class. You're allowed to change this as the design progresses. Once you have all these classes, attributes, and methods, you can create a UML diagram for the project. Notice you haven't done any coding yet. The goal is, if you have created a fairly good estimate of what's happening in terms of what classes you need, what attributes they have, what methods they have, then the coding becomes a lot easier. In fact, were I to code this, the first thing I would do is create all of these classes and all of these methods, and the methods would be empty. They would be meaningless methods. Why would I do that? Well, then I'm going to remember, once I create my UML diagram, I'm going to pick the first user story that I'm going to work on. And in order to do that, I'm probably only going to do one method in one class. But I need to test it. And I can't test it unless I have all the other classes with their methods. So what this does is it helps you as a programmer to focus specifically on what you need to do for that one user story. I'm only going to change this method. You don't get into this, or maybe you'll have to modify a method. You don't get into this mess of, oh, I changed something in this part of the code, now I've got to go change it over here, I've got to change something else over there, I've got to change something else over there, and then you get lost in this whole confusing labyrinth of all the changes that you're making. The idea is You already have the basic layout. Your code already exists. It's encapsulated in these objects, so modifying one object hopefully will not change another. If it does, it only changes the object that it's directly related to, so you don't have to run all over your code figuring out what needs to change. And you can focus on that one user story, get that one done. Now, a variant of this is that you develop the test cases for each user story later. Basically, when you work on a user story, that's when you develop the test cases for it. And that's both of these techniques are common. In this class, it's more appropriate to say that I'm going to ask you to build all your tests and requirements up front. The advantage of doing it the second way is that because you've already laid out all of your objects and classes and you're just focusing on a single user story, is you may have some better language to write the test cases with. Okay, I'm going to stop here and then I'm going to talk about test cases and requirements in the next lecture.